Hola, hi, wagwan everyone. My name is Carlton Saunderson and I'm a senior math major at Florida Gulf Coast University. And today we'll be focusing on understanding how to solve marginal profits using linear programs with constraints. Thank you guys for watching and let's get to it. We have a linear programming problem. Suppose that a company has two products with marginal profits of $6 and $4 respectively. The first product requires 2 labor hours. The second requires 1 hour of labor, and you have a total of 12 hours of labor daily. Each product requires 1 unit of raw material, and a total of 10 units of raw material are available per day. We obtain the following LP problem. Find the maximum value of z is equal to 6x1 plus 4x2, subject to constraint. We see this from the opposed supposition. Now we seek to find the maximum value given the constraints. So first, we will note that x2 is greater than Suppose your company has two products with marginal profits of $6 and $4 respectively. The first product requires 2 hours of labor. The second requires 1 hour of labor. You have a total of 12 hours of labor daily. Each product requires 1 unit of raw material, and a total of 10 units of raw material are available per day. We obtain the following LP problem. Now we need to find the maximum value of z is equal to 6x1 plus 6x1 plus 4x2, subject to the constraint which we've been given from the above supposition. 2x1 plus x2 less than or equal to 12, x1 plus x2 less than or equal to 10, given x1 and x2 is greater than or equal to 0. First, I have written down what we should note, that x2 is less than or equal to negative 2x1 plus 12. We transcribe this from the above constraint. Now, we will transcribe again. x2 negative x1 plus 10. Now, from the given, we will now transcribe the tableau with the given constraints and slacks. So, from where z is equal to 6 plus 4, we put then we put and then 4. Okay, now we seek to use row properties to get the solution. Using these row operations, we can now test to verify graphically whether this is correct or not. From the tableau, we can easily see that x1 is equal to 2, x2 is equal to 4, or rather 8, my correction, and z is equal to 44. We will now test this graphically. Okay, my hand isn't that steady, but bear with me. Now we see to plot these lines, and now we seek to find our feasible region, which we shall do by shading. Let me get my highlighter. I'm not gonna use too much of the highlighter. You guys get the gist. Now we know that z is equal to 44. Now we have the next question, which says, if you can increase the right side of the first constraint by one more unit, how much more profit can you make? How much more profit can you make if you increase the right side of the second constraint by 1 unit? Here I've already solved that the shadow price is $2 per constraint, but I will be showing you guys how I was able to transcribe this shadow price. So, given that if z is equal to 96, we know that x is equal to 3, or x1 rather, and x2 is equal to 7. So there can easily be seen that if first constraint is increased by 1, then it will double the profit. Same can be said about constraint 2. So if it's doubling the profit based on the constraints, we can easily see that the shadow price is $2 per constraint, given the fact that if we had made some adjustments to x1 and x2, then we would have, for whatever the constraints would be, then we would have doubled the maximum value, which we've seen here that we got a new maximum value right here. Now let's proceed. All right, now we have this new problem that says find the minimum value of w is equal to 12y1 plus 10y2, subject to constraint 2y1 plus y2, which you see right here, is greater than or equal to 6. y1 plus y2 is greater than or equal to 4, given that y1 and y2 is greater than or equal to 0. So now we'll see to try to find this graphically. Given that we're trying to find this graphically, we should note that negative y plus 4 is equal to 2y plus 6. This is given from transcribing these values, that y2 is equal to 6 minus 2y, this is a minus right here, y1, and y2 is equal to 4 minus y1. So from this we can see that y1 is equal to 2 and y2 is equal to 2 also, given that C. So now we'll see to try to graph this. My graphs might be a little sloppy, but bear with me. Now we'll plot the graph. We know it crosses here. And then we know that it crosses somewhere right here. And we know that somewhere right here is where Z would be the max, which would be 44. So when shading a feasible constraint, we know that it's any part that is shaded with the highlighter. Hope you guys are being safe through coronavirus. Now we will try to find how much it would cost if you could save, how much cost could you save if you could decrease the right-hand constraint by 1. We can easily see that if you were supposed to decrease the right-hand constraint by 1, that you would gain $10. So that's easily seen. So we transcribe the answer will be $10. So I pre-wrote this information that if Z is equal to 4, then we know that W is equal to 44 rather. And if Z is equal to 44, W is corresponding to 44 also. They, using the similar information of how I solved the previous problem that I did before. So here you'll see where I transcribed what Y2 was, and then I followed up and found what Y1 was, and therefore found what W was. And my W came to be 75/2. Here I have represented it graphically and shaded appropriately. Here it asks you to formulate the dual LP problem to the one in problem 1, then use the Sage LP solver to solve the problem. This is something that you guys would have to do on your own, so I wrote out that you could go online to Sage Math and plug in the minimum or the maximum, but here we have minimum, and the constraints as represented in the simplex tableau that we did in similar questions below. That's that tableau that we did with previously. Simplex tableau. So as you do this, you'll be able to solve the problem.